All right. Any questions specifically about the homework? Because we'll go over the lab more in a little bit. I'm not saying it's not to say you can't ask questions now. It's just that I will go over that more regardless. So I want to make sure that everyone's fine with the homework. And if you are, that's fine. I'll just move on. All right. So, okay, first things first, general stuff about the lab. I think that's most important for me, by and far, are grades. So, so this has been kind of a nightmare. I really was super hoping to have to submit everything to you, and I was going to tell you all about them this morning. But unfortunately, I had to sleep one of these nights, so that's what happened last night. So I didn't have the time to put them in. I don't know why I'm actually holding back so much, because I have a lot of the entries. I just have some holes from some students, and I don't know if those holes are from the students not submitting lab report, or if there's something wrong on my end. But what I'm going to do is, after this lab, after the proctor, I had to proctor the exam at 10:30, unfortunately, but I'll still monitor the Discord. So if you have more questions there, then ask me them. I'll just upload whatever I have. So really want to have those two today. That doesn't even matter at this point. The thing that I decided that I was going to do regarding this, to try to make up some of this, because I think it's super lame and crappy to not have the grades in for you guys. First thing is pretty straightforward. When I was grading, I found that if you're making a mistake and you've repeated the mistake throughout multiple reports, so I guess I could try to give you an example of some formatting. Let me like write in the text. So I will have something like this. So I'm going to send you guys an email later tonight. Let me open this up in chat. How do I do that? How do I do that? Okay. So I'm going to send you guys an email later tonight, and you'll have like an entry like this. Because I mean, I have things in my own lab book, but this is just easy for me. So what I've done for each of the lab reports is I've divided it into sections. So the very first one is background. Second is actually, this is, I don't know why I have the things here. The first step should be the objective. Second step is background. Third is, I think actually this is just cut off. That's why. No, it's not cut off. I'm not sure what's wrong with this one in particular, but the first step, objective, is worth 5 points. The background is worth 10 points. The procedure is worth 5 points. The results are worth 5 points. The calculations are worth 20, and the conclusion is worth 10. I think this is actually because this is maybe for, I don't know what's wrong with this individual sample I gave you, but that's how it normally is. Actually, this is not how it normally is. I need to just rewrite this because this does not make sense. So the very first one, the background, I have the objective. So let's just rewrite this. This is kind of silly, but I want to have this actually written correctly for you guys. Objective, background, procedure, results, calculations, and conclusion. I will send you guys a result. I will send you guys something like this, which is 5 plus 10, 15 plus 5, 20, 25, 10, another 5, 40, 30 and 40. So yes, that should be worth 20. So I will send you guys something like this for each lab. And it might vary depending on the lab. For example, for lab, the second lab was a simulation lab, and so that will have like we don't have the background and procedure for it. So the calculations can be weighted a little bit heavier, and as are the results or the conclusion, perhaps. And this might vary because I just want to have something to right now. Anyway, the most important part of this is that I have in the comments, I'm going to write down a general review of what you guys did wrong. Normally, I was just going to have you guys come back to give me feedback, but I want to do this so that you know if there's a common mistake. So my policy will be, if you have a mistake that you've repeated more than once, whenever I see it pass the first time, I'm just going to note that you had that mistake. And then I'll give you the option, you'll have, I don't know how long, right now I don't have a deadline, but I mean, probably not all at the very end of the semester, but you could do that since that's kind of fair. That's what I've been doing too, guys. You could have it all, so I want you to resubmit with the correction. If you want to resubmit the whole lab and just highlight the correction, that's fine. You don't have to highlight it even if you just do that. I know what you did wrong. And then you can get those points back and not without penalty. Basically, that's my way of saying, well, if you're making a common mistake, or if you made a mistake repeatedly, I would have told you this earlier in the semester. And because of my own problems, if you're making a mistake repeatedly, that's something I should have corrected. I haven't corrected it, so this is my way of giving you points back, to be fair. In addition to that, something I thought about was, basically just giving you more flexibility with things. Of course, personal things can come up, and let me know when that happens, because I mean, I'll be more inclined to give flexibility for that. But even personal things aside, what I've decided to do is for each week that I wanted to give you something and it wasn't there, I'm going to give you 1 day of flexibility. And when that's accounting for each assignment. So for me, that was the very first spreadsheets, which I have all of them minus a few because I just don't think that people submitted them. So I don't know. So I've been holding on to them for some reason, but it doesn't matter. So that's 4 weeks ago. And then 3 weeks for lab 1, 2 weeks for lab 2, 1 week for last week's lab. So 10 plus 3 plus 2 plus 1, 4 plus 3 plus 2 plus 1 is 10. So the conclusion is that I am going to give you guys, all of you, 10 days of flexibility. So I have in your spreadsheets, I have a column that indicates like late days, basically. So you have 10 days of just extra flexibility that you can use on any assignment. I would prefer, or I would suggest using them on the lab reports. But what that means is, for example, the lab that's due today, if you wanted to submit that tomorrow, then you can just use 1 day of that. Then you have 9 days remaining, and you'd have no penalty for this report. You can use it however you want. You can use all 10 days at once. You can use them throughout the semester. So basically, that's my way of just trying to make that up. I can see when you submit things on Dropbox, so it's fine for me, and I'll just keep track of that. But hopefully that gives you guys a little bit more flexibility, and that's some way to, I don't know, I guess just to repay the kindness, flexibility to flexibility. Because I mean, I don't want to not have the grades too, but that's the reality of the case, and so that's something I thought of. If you guys think of anything else, then I know I'm open to ideas. So yeah, so the 10 late days policy, the what was the very first one? Oh, just the feedback, so you can get the points back on repeat mistakes. And lastly, I guess I'm just going to submit whatever I have, even if I don't have every individual student stuff, because some students there are gaps. And I'll send those to you by email. I'll show you the grade distribution for each of the lab reports. So I'll show you how many points each section was worth and then what number of points you got out of that. And then instead of commenting per individual section, I'll also have a comment at the very end that said like, some things will be pretty intuitive. So I can just say like title on an objective or something like that. But I will mostly try to highlight repeat mistakes or just like something that you can do if it's not repeat, like what you should have done to make this better. So
I have a question. So if you're grading our lab report, are you going to submit it back to us via email? And then that's how we see like what we did wrong, and then we can correct it and send it back to you?
Yes and no. So what I was going to do is I was going to send you guys individual email. Otherwise, because actually I think I can put comments on the grade sheet, but whatever. I was going to send you guys individual email with that distribution. And at the bottom of the grade report that I give you for the sheet, I'm going to write the comments. This is so much easier with an actual report because I can write on it and I can highlight it, and some things are pretty easy to express just with like, simple shapes. But it's more annoying to do that with a computer, or at least with my computer it is. So what I'm just going to do is I'm just going to write it out manually with comments. And so I'm just going to say that on this report, you have like, you'll see the distribution where you got points taken off, and then I'll write on the bottom of there the comments, or you'll see this, for your results, you didn't include this. For your conclusion, you explained, like, you didn't go into enough error analysis, or you didn't explain how you got the results. Or for the calculations, see question 2, see part B, question 2, something like that. Basically, you'll see where you got the points taken off, so it's not like it's like magic to you. It should be pretty clear. But for the most part, it's just going to tell you where you got the points off, what you could have done better if possible. That's mostly true for some things I think are pretty intuitive, but that's mostly true for like explanations, I'd say, in the conclusion, or maybe in the background or the objective, something you're writing out, it's more easy to comment on. The math, probably for the math, it makes most sense just to give you feedback depending on, how much feedback you want necessarily. It's difficult to give every single individual student 100% feedback on it. But certainly I can just show you, like, if you wanted more detail, if I didn't already do this, the individual equation. Like, I'm definitely gonna tell you what question you got wrong. But I don't really want to just give you the, I guess I could just give you the answer. Well, anyway, so far I just have told you like what the question was, like what the question was wrong. I'll think about what to do for, I'll think about for the calculation section, if I just want to give you like the correct calculation as a whole, or if I just want to give you the answer and you can figure out the calculation where you went wrong. I want there to be a little bit of thought on your end, but at the same time, I want to make it, inaccessible. So I guess
Thank
I just got to get back to you on that. But you should be clear what you got off. That part is, there's no ambiguity. It's just a matter of how much I'm telling you. And regardless, there will be definitely enough to not make that mistake in the future. That is a bare minimum.
So if we did our calculations, and then if our calculations are wrong, but we explain why they might be wrong in the conclusion, do we still get the points for it?
You will get most of the points, yeah. Okay. So you'll probably get some. So you'll definitely get full points for the conclusion as its own individual section.
Okay.
Probably, I mean, you don't get full points, but you'll certainly get a lot less than if you didn't explain that. And it depends. It's kind of a case-by-case basis. So I wish I could have a full answer for you. But like, for example, this current lab that we have due today, there are different possible answers you could have given as the empirical formula.
Okay.
That sounds crazy because there really should only be one. But it depends on how you interpret the data. And I don't mean to sound cheeky about that. Like it literally depends. There are different valid ways to interpret it. And if you tell me about those and if you show me, that's fine. If you got a completely nonsensical answer and you wrote in your conclusion that I know this answer is nonsensical, but it's nonsensical because I did this and the thing. If basically your technique was totally right, but your answer was totally wrong, for this lab, I would give you 100% points.
Okay.
Like as long as like you somehow followed the correct technique and then you got this answer and then your conclusion, you're saying this answer doesn't make sense, but that is literally the answer that I had to get. Well, then there's something wrong. You didn't do anything wrong, right? So basically, I'm only going to take off points for things you did wrong. And I would say in general for this lab, try to focus on understanding the technique and trying to understand the technique. The actual numerical grade, the actual results are not worth as much as the explanation for the results. And I don't just mean that for the conclusion, I mean that for the calculations too. Like you're graded significantly, like for the calculations, I would say certainly more than half. I mean, I guess there's some variation, but the majority of the points, let's just put it that way, the majority of the points are actually in just having the correct calculation set up, whether or not your answer is true. So even if you had the correct setup with the correct numbers and you're doing the right formula, but you had the wrong answer, I mean, that's probably usually like 75%. So it's pretty significant. And that's not a bad grade in this class.
Thank you.
All right, any other questions? Okay, if not, then we will move on. Just formalize this. Just make sure these two students are here. Nope. Okay. So, all right, let's move on. So this morning I sent you guys something which was I guess everything you're gonna need for this current lab. So apparently you didn't have that in your lab manual. So of course that means you could have done a pre-lab because you didn't have any material. You guys don't have any questions on the homework, so it seems like that's straightforward and fine. The homework is kind of a prep for this lab. Anyway, so let's just talk about this lab. So this lab is a little bit cool in that it is one of the two labs that you're actually going to do. So it's kind of an actual, it's an actual chemistry lab. That's cool because now there's going to be some variation amongst your guys' results. I think there's a little bit more critical thinking involved because you're going to actually not only have to do it, but there's going to be, since there's going to be variation between you guys, you're going to have to debate whether or not this is significant. That's much more straightforward when I give you guys the data, because like it's like I know what the value is supposed to be. We all talk about it, and like I don't know, it's just more streamlined. But when everyone has different results, whether or not something's significant, you really only know by looking at your technique and saying like, yeah, in the conclusion, I'm confident with these results because I did the technique right. And so what I'm proposing to be the true value of whatever it is we're looking for, the objective, these results seem true because my technique was valid and I didn't have problems with it. So hopefully that's more straightforward for this lab. So in short, this lab, we are exploring the ideal gas law. That's the chemistry. Like that's some of the background that you guys should be familiar with is with the ideal gas law. I guess you guys should also be familiar with the chemical reaction that happens, but what is all this we're actually doing in the lab? In this case, we're doing in the kitchen, and that's that we are just baking cookies. Pretty cool, because you actually get to eat the chemistry. The primary reagent, the chemical that we're analyzing is sodium bicarbonate or baking soda. So it shows you the reaction in the PDF that I sent you guys earlier. That is the dissociation of sodium bicarbonate, that when it's heated up, it will produce sodium carbonate, so stronger salt, water, and also CO2 gas. So the CO2 gas will, it's a gas and it's forcefully exuded, or it's exuding a force on the mixture that is the cookie batter around it as it escapes from the reaction with heat, with I guess the input of heat. And as it does that, it will inflate the cookie batter or help it rise. So the background here is that if we, I guess the background is if we know the temperature, and if the temperature is directly related to the amount of gas that's produced, the higher the temperature, the more gas that's produced. And if the amount of gas that's produced is directly related to the volume, there should be a relationship between the volume of the cookie and the temperature. And theoretically, we could also try to determine, I don't know, actually, let me look at the procedure. Let me look at the manual because I want to see how deeply she goes into this. Because I was going to say something, but I don't know if we're actually going to go over this, so I want to make sure. But theoretically, you could actually measure the amount of sodium bicarbonate that reacted with the volume. I don't think we're going to do that. So basically, we're examining the relationship between volume and temperature. And you're going to plot that. It's kind of cool though, because the relationship between those two, the rate of this, or the line, the actual linear relationship or nonlinear, will be indicative of the actual reaction kinetics and dynamics. So that's pretty interesting. How deep we can go into that is probably debatable. It looks like that's as far as we're going. So that's exciting. Some things to note. So I sent you guys a video, and in the video, Caleb doesn't give you a class. He doesn't give you the whole set of data. You're going to need to have a few data points. I think, let's see, you need to have at least 6. And I do not think you need to have trials for individual ones, unless you do. I think you might actually. No, you don't need to have them. So regardless, you need to have at least 6 cookies cooked at different temperatures. You don't need to have individual, you don't need to have trials. So for example, you don't need to have 3 cookies baked at the same temperature, and then another 3 at a second, another 3 at a third, so on and so forth. You just need to have 1 at each temperature. And then you're going to take the dimensions of them, and then you're going to calculate the volume, and then you're going to plot a relationship between the volume of the cookie and the temperature. The objective is, well, I shouldn't tell you. The objective is, does anyone want to talk? Well, actually, you guys can look at it. So let's just talk about that afterwards. We can, after the proctor session, I have to go to at 10:30. That should finish by 10:45. So if you guys want 11:45. So if you guys want to come back 11:45, I'll open up another Zoom meeting and we can talk about everything. I'll just give all the answers basically out then. Some technical notes for the cookie lab that you guys will need. So you need to have access to an oven. Dr. Fuller said that if you have a microwave, that should be sufficient. That doesn't make a ton of sense to me, since the temperature should be known. I'm guessing what she meant by that was that if there are different settings on the microwave, if there are different heat settings, it's possible that you could just use, like, heat setting 1, heat setting 2, even if you don't know the individual temperature. And you could still track, you could still make a chart. It's just a little bit less informative than that with an oven, or something that you can just a little bit more quantitative. If you have a toaster oven, that should also work. But a few students have reached out to me that they don't have any of these things, and that's understandable. So if that's the case, then just email me and let me know that, because I'll just send you what Caleb's data was, and you can use that. So in other words, it's going to be like every other lab. But I've been very strongly discouraged to give you that data unless that's like your physical reality, because we want you guys to have to do as many labs as possible, because I mean, that's literally the nature of this class. This is kind of crazy, I think, to do all this stuff online. I mean, it's understandable given that the situation. It's just that you learn so much by actually having to do this stuff. And so really, I would heavily encourage you to, on a personal note, to do the lab, because it's something that's pretty straightforward. We can all do it. And I think you learn quite a bit more when you actually do the lab and you are analyzing your own data. I think that's actually mostly it. I mean, when you're doing the lab, you're going to need to have access to something like a ruler. I think Caleb uses, I forget what they called, but they're for more accurate measurements. You can actually have 2 ends of it. I always forget what these things are called, but you don't need that as long as you have some means of measuring it and you use that same measurement tool each time. So just like a basic ruler should be sufficient. And that's all you need. Maybe another technical note is for the procedure. I would not go crazy writing about the cooking procedure. On the very first question of the lab report, so for the data sheet, actually not the question, that's the not page given, but for data sheet question 1, it asks you what kind of cookies you made and the name of the recipe and the baker who wrote it. So basically she's asking you for a citation. You don't have to, of course, report it as an actual citation, but you can report it but you should report it. And this is basically my way just to gauge. This is my way of minimizing the work you have to do in terms of writing procedure, because then there's going to be some redundancy. Of course, you might argue, well, then I should, have been able to do this for my lab manual, but this is not a cooking class. It's a chemistry class, so we have to talk more about the chemistry. Anyway, for the procedure, you can say that you followed this this cooking procedure. That's fine. You don't need to go into detail about it. If you want to write it out, that's fine too. I mean, you can. It's certainly up to you. What I would definitely mention and what I would strongly emphasize in the procedure is the actual chemical analysis that you did on it. So you'll see in the video, and what you'll have to do is you'll have to be really accurate and precise in terms of measuring the volume of the individual cookies, because if we want to analyze the relationship between temperature and volume, of course we need to make sure that no other variables are at play, right? So we need to make sure that everything is constant. The only thing that's differing between each trial is temperature. And so we want to see if volume varies, then then it has to be as a result of the temperature change, because nothing else changed. And this was from the same mixture. So you'll need to emphasize how you did that. How did you make them equivalent? Again, Caleb shows you how to do that. If you have measuring tools, which you should if you do any cooking, it's really pretty straightforward. And then you should also indicate, how much sodium bicarb, how much baking soda did you use for the cookies, and you also want to talk about how you measured the cookies, and that's important also to talk about what instrument you used, because for this last lab that we did, there's a good amount of uncertainty. There's uncertainty for each of these labs. And part of that is because the instruments are not super reliable. And so if you are using a kind of, a first grid ruler, it's difficult, let's say, or that instrument's not super reliable. And if you use that, it's fine. That's what you had. But that's something for the conclusion in terms of talking about how reliable your things were. Maybe if you see weird discrepancies in your curve, then this could be explained by the uncertainties resulting from the ruler. All right, does that make sense?
Yeah, it makes sense.
Okay. All right, well, I mean, that's actually mostly it for this week. In some ways, it's really straightforward because we've all baked before, I hope. So it's pretty easy, and then the measurements are easy. It's not dangerous. The most difficult thing about it is that we actually have to do it, but at least it's fun. So that's that. Okay, so for last week's lab, which is due at noon, so you still have some time. I was talking with a student about it this morning, so I want to, first I just want to open it up. Do you guys have questions about the lab specifically that we can get addressed?
I guess my math was a little off, I guess, because I get for the empirical formula, I got something different. That's it.
What was it? What was the actual value that you got?
It was ZN2CL5.
Okay.
Yeah.
Oh yeah. I think I know what you're talking about with that individual. Wait, no. Yeah, that's fine. So okay, so this is something that I was hoping you guys would bring up. I mentioned a number of times over this pre-lab that there's a good amount of uncertainty. Okay, so did anyone look up zinc chloride to see what you would have expected that to be?
Yeah, ZnCl2.
Yeah.
And yeah, I searched it up, and then I mentioned it in my lab report too.
So it should be, there should be 2 chlorides per 1 zinc. That's also the actual thing that we're making. So we didn't
Yeah.
observe that. And if you guys got ZN2CL5, that is actually to be expected. So that's just the answer you got. That's why when Rachel was asking earlier about the calculations and basically like writing in the conclusion, if you know this is wrong, but you wrote this anyway. So that is the ZL2CL5 is both right and wrong. It just depends on how you see it. It's wrong in that that's not the actual substance that we made. It's right in that as much as we could tell with the instruments we used, that was literally what we determined it to be, which means it's the right answer for this lab. If we had better instruments and if we did multiple trials and if we had made sure that there were no problems, we could have taken the average of them and we probably would have got an empirical formula that was within reasonable confidence interval limits that was ZL1 to 2 chlorines. But we didn't do that. We only have 1 trial for each of them that had a lot of instrumental uncertainty, and there was probably some experimental error on my part. You can talk about. I'm trying to think, what could I have done wrong?
Is it because the balance or something? Because I noticed it was moving very hard. Like, yeah.
That balance is crazy. So realistically, even though the balance is supposed to have an uncertainty of 0.0 to 0.1, I mean, I don't know if you guys could see it in the video, but those balances are impressively unmaintained. They're literally degrading with salt. they do not look good, and there's a huge amount of fluctuation. They probably would have been okay if they were maintained. They're not analytical balances, but they're okay. They're pretty accurate to have an uncertainty of 10 milligrams. That's pretty good. So the easiest answer here is that the mass balance had a really high uncertainty. I would say realistically, an uncertainty 100 to 50 milligrams is to be expected for this. And considering the differences in weight, that's pretty huge, which means when you look at the confidence interval for like the actual numbers, it's really, really big. We didn't do that. I didn't make you guys do that. But just you can just think about it conceptually. The margin of error is really large, which means that when you do your point calculation, because you have one data value, we're not looking at uncertainty, we're not looking at a range around it, we're just saying this is the data value. It's like it's 100% this thing, no doubt about it. Except that it's not really 100% this thing, no doubt about it. That's what we used, but really it could have been within a range of things. So if you guys just use the point values and then you said like for part A that you had, ZL2 chloride 5, there is nothing wrong with that because that is following the math correctly, following the way to generate the empirical formula. That is what you're supposed to do, and that is the correct value. If you guys thought about it more deeply and you thought about the uncertainty in your lab and you said, well, really, this is what I got, but it's not unreasonable to assume that I can actually, estimate with this uncertainty that it's actually closer to 2. Like, okay, so we can actually change both values, right? Let me pull up the data. You can change both values. So the chloride value is abnormally high for the zinc. With the balances that we had, basically we could either estimate that the mass of the zinc chloride was actually less than what we used, so less than 1.08 grams, or we can estimate that the mass of the zinc was higher than what we used, which was 0.46 grams, or we can do them both. If you fluctuate that a little bit, like let me just do this right now. Let's say that the mass is actually 0.5 grams and the mass of zinc chloride was 1.0 grams. And then we get a ratio of 1 zinc, obviously, to 1.84 chloride, which looks a lot closer to reality, right? And that's within reason, right? I went and changed the zinc mass 0.04, which is definitely less than 0.1. And I changed the zinc chloride mass by 0.08, which is still less than 0.1. So it's within margin of error. It's still not quite there, but it's much closer. If I were to do the exact same thing and say we have mass of 1 gram for zinc chloride and then a mass of 0.56 for zinc. Whoops, actually want to go the other way around. A mass of 0. Wait, no, I do want to do that. 0. Am I doing wrong? Actually, if I just kept the mass, if I changed it slightly to have a mass of zinc chloride of 0.48 grams and then a mass of zinc chloride is 1 gram, then it's exactly a perfect 1:2 ratio. In other words, those are both within the margin of error, and we could have very easily gotten those as the true value. It's much easier to say actually for part B with copper sulfide that we produced, because they're already really close to 1:1, which is the true value that we should have been expecting. That's not what you guys got, or it's not what you should have gotten. But it's pretty easy to say that within the margin of error, we could have gotten 1:1. So I'm kind of just directly telling you guys the answers right now, but you still need to prove this to me, of course. But basically, what I'm saying is that there is more than one possible answer that you could have proposed. And based on how you defend that answer, you can get full points or less than full points. Because if you gave me either the possible, there's probably even more than 2 possible answers for each of these. If you gave me those 2 values, but you couldn't defend it properly, or there was something wrong with the calculations or something like that, then that doesn't give you full points, even though the answer is correct. So keep that in mind. That's actually the main thing we wanted to discuss for this lab. The other thing we wanted to discuss was that there's I think I told you guys about this, but in case I didn't, because I saw this problem come up, there is a typo in the lab report on part B for determining the percentage of sulfur in copper sulfide. I forgot what it asked in the lab, but it asked you kind of something nonsensical. Like it says to divide 2 lines, it didn't make sense. So for that, I want to make sure that I'm actually saying this correctly because I'm just going off memory. So just be aware that I think it's for that part while I'm pulling up Discord so I can see exactly what the problem was. Beware that for part B there was a typo, and that can happen. So beware. Dr. Fuller rewrote this lab manual this year, and while I think it's pretty good, it's much more like an actual lab manual should be at a large public university compared to how it used to be. There are still errors that will be in there, undoubtedly. So if in doubt, you can ask me, or if in doubt, really, I would use your brain and think about what's actually happening chemically, and does what we're asking you to do make sense? Because if it doesn't make sense, then trust your intuition or trust your logic. And lastly, if neither of those 2 work, for example, like if let's say I don't respond to you in time, or you're not sure if this is actually true because you guys are students, right? So it's natural. You're not going to understand everything all at first. You can just write in your in your conclusion that I did this, but there may be some error here because of this. I thought maybe I should have done this, but I wasn't sure. If you got points taken off because the answer is wrong, but you told me that in the conclusion, I would definitely give you points back for that. No doubt about it, because that shows that you understand that there is a problem, and in fact, you understand the material so well that even though you don't know how to fix a problem, you can recognize it is a problem, and it's clear enough to you that you're actually doubting. You're doubting what we're telling you to do. You're doubting institution, which has a lot actually. So don't be afraid to do that if that's the case. I want you guys to you think about it independently and think about it critically. All right, I did a lot of talking at you guys. Does that stuff make sense? Do you have any more questions about the report? Because those are the primary problems that I remember. At this point, really, I don't know what to say, actually. I covered most things I want to talk about. There was no questions on the homework, that's fine. I posted the next 2 homeworks this morning, so you can access them now. Next week, we're going over redox. Nothing really crazy there. The redox is in the lab manual, so you can refer to that for more information. You should have Caleb's video. I emailed it to you guys. I can post those two things in the Discord if you want me to, so I will do that too. I told you guys about the late things, as in they'll give you the extra days. Keep in mind that if you have a personal thing going on, this does not count towards those. That's separate. Those are free days, period. Like I'm not counting them. That's like if there's like an emergency that comes up, I know this has come up. Basically take the time that you need and then finish them when you can. Life happens, and especially with the time we're living in with this pandemic, the whole damn reason we're online in the first place is because there's a lot of life happening outside of lab. So that's fine. Just let me know if that happens and we'll work it out. But you have the 10 days that you can use at your discretion. And this is counting. If I don't get back to you, you're gonna have even more days. So it's gonna help you hopefully, but I don't want that to happen, not because I don't want you guys to have more days, but just because I want you to have this stuff. It's another way for me just to keep myself accountable too, and also to make sure you guys have more flexibility. And so I'll send you guys the individual grades with the comments. You can resubmit for recurring problems for the full points back. I went over lab 4, that's due at noon. And then went over this current lab for this week. So that's that. All right, so if you have any problems, let me know. Like I've said a number of times now, I would really encourage you guys to use the Discord for lab help in particular. I really like that because a lot of people are pretty active on it, and it's at least one thing that I can keep on top of. I get a lot of emails from a lot of people, and I'm unfortunately drowning my own work, and so I have a natural avoidance to my email. I don't have that to Discord though, because it's just these labs, and then you guys help each other out, and it's much less formal. I really like that. So if you guys have like last minute questions or any kind of questions regarding the lab, you can just ask them there, and that tends to get answered much more quickly. And even if I don't answer, another student answers it, which is really cool. That's everything that I have to say, I think. So, okay, well, I'll be here. Just note that at 10:30, I have to do the proctor. You guys don't have to be here anymore. We're finished with everything. So if you want to bail, that's fine. But yeah, I'll be here. I'll monitor the Discord. I kind of consider that to be the extension of this Zoom meeting because it's just more convenient than keeping the Discord on. Also, I had to literally log on to another Discord to do the proctor, so I can't stay here. But yeah, just let me know if you guys have problems with something. I guess the last thing I want to mention, again, I already said this, but just to reiterate it, just to make sure that everyone's on the same page. For this current lab, for the solutions lab, the chemistry lab, I'm not the chemistry lab, but the cookie lab. If you don't have access to the cooking supplies, then let me know and I can send you guys the data, but please do not do that unless you like literally don't have access to it. It's happened, it's fine. Like if there's some other crazy thing, it's fine. I'm not gonna hold it against you. I would just largely encourage you to do it on your own if you can. Yeah, that's everything. So I'll stay here for a few more minutes, but if you guys have any questions, then that's that.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.